Hello and welcome to this short introduction of DevOps. By the end of this session, you can expect to know about a basic definition of DevOps. Why does the whole concept even exist? How can DevOps help us improve our traditional IT processes? How does it really fit in the whole Agile world? What is the typical life cycle of a DevOps process? And lastly, some of the common terminologies used in the DevOps world. Let us start with the basic definition of what is it. DevOps can be best defined as a culture that promotes collaboration. Collaboration not only between development and operations, but also between business stakeholders and developers. As the name suggests, DevOps is a combination of development as well as operations. Primary goal for DevOps is to allow the application code to be deployed faster and in an automated way, which of course helps organizations to reduce their time to market and cater to their software demands better. Now that we have a bit of idea about what is it, the next logical question is why is it? We know that the software industry existed since years now, but why is there a sudden hue and cry about DevOps? We never heard about it before. Well, the reasons are many. The first one being that there is an increasing demand from business stakeholders to increase the rate at which software is being delivered to them. Therefore, an automated way to deploy software is needed so that the time to market can be reduced. Secondly, manual code deployment process is not only troublesome but also prone to errors. One of the main objectives of DevOps is to improve collaboration between teams. Originally, developers are the guys who build the application, and operations consist of people who deploy it on production server and then maintains these servers. Now imagine a situation when the application breaks down during or after deployment. These two guys have to work together to make sure that the whole thing is seamless. Next is the need of being agile. Agility implies that you have to deliver working software every sprint. Therefore, there must be a way to automate deployment so that there is more time to develop new features. Because of automations, your turnaround time is faster, thereby reducing the time needed for each development cycle. Since you are working in an automated and repeatable fashion, the whole process is much more immune to errors. All these reasons we just discussed contribute to increased efficiency. Now, how is the whole thing so different from the traditional IT world? Let us have a look at some of the basic differences. In the old IT world, people with similar skills were bound together to benefit from economies of scale, whereas DevOps makes use of cross-functional and self-sufficient teams to ensure that all the required knowledge to run an application exists within a team. In the old IT world, milestones such as releases and deployments were seen as high-risk events because when things go wrong, a lot of firefighting, escalations, and blame game is happening. However, in DevOps, such things are discouraged by emphasizing on running frequent automated tests and also frequently merging new functionalities into the main code base. Traditionally, releases have been time-consuming, costly, and expensive. Therefore, developers were only allowed a few releases in a year, whereas DevOps believes that smaller batches are easier to handle and the negative impact, if any, is minimal. Since failure in the old IT world is time-consuming and expensive, they have the inclination towards being a failure-proof organization, whereas DevOps believes that failure is inevitable. Therefore, fail early when the cost is lesser and learn from it. Now, we have been delivering good software even with Agile. How does DevOps fit in there? Usually, in a software development process, you have three parties involved. First is the customer or stakeholder or the requirement owner, followed by development teams who meets these requirements. And then you have operations guys who deploys these requirements. Agile focuses on addressing the gaps between stakeholders and development teams, whereas DevOps focuses at addressing gaps between development teams and IT operations. While Agile emphasizes on continuous integration and monitoring, DevOps emphasizes on continuous deployment. When you think of a typical DevOps lifecycle, there are 8 processes involved. These 8 processes can be further classified into 5 broad categories. The first such category is continuous development, that includes plan, code, and build. These 3 processes are typically governed by Agile, where you continuously develop and deliver in sprints. Agile tools, Git, and Maven are some of the tools used in this process. The next category is continuous testing, where the code base is run through multiple automated tests. Selenium and JUnit are some famous tools used to carry out automations here. Continuous integration is the process where new functionalities are regularly merged into the existing code base. Jenkins is one such famous tool that makes it happen. Continuous deployment is the stage where your new functionalities are continuously deployed on production and staging environment. Puppet and Chef help us achieve just that. Continuous monitoring of production systems is aimed at improving the quality of software. Nagios is a popular tool used in this process. The whole DevOps lifecycle is denoted by infinity because development, testing, integration, deployment, and monitoring are continuous processes. The last topic for today is getting to understand some of the common terminologies used in the DevOps world. First is cloud computing. Although this topic is not just related to DevOps but comes up very frequently during such discussions. Cloud computing is when the computing resources that you need to manage your software application is available to you as a service. Its pay-as-you-go model undermines the need for maintenance of highly expensive data centers. Immutable infrastructure is an application hosting environment that's either too difficult or impossible to change. Even if you need to change one configuration component in such an environment, the whole setup needs to be reinitiated. While disadvantages such as inefficiency is obvious, such setups are extremely robust and reliable. Infrastructure as a code is an approach to infrastructure configuration that allows us to start, set up, and dismantle servers via automated scripts. Obviously, such a process of managing infrastructure is so much more efficient than time-consuming and error-prone way to do it manually. Microservices is an application architecture in which the whole software application is divided into multiple smaller and loosely coupled components. Such components then communicate with each other via commonly used interfaces such as APIs and REST. Serverless computing is a type of service which allows you to make use of computing resources on demand without having to run or configure any server environment. CI/CD, that's probably the most common used terminology in the world of DevOps. While continuous integration ensures that the code with new functionalities is pushed into main code repository several times a day, followed by running automated unit tests and making the build ready. CD, that is continuous deployment, ensures that if the tests and build were successful, the new application version is deployed to staging and production automatically without the need for any service downtime. Container. Container can be defined as an envelope that allows you to bundle your software application and its dependencies together. This is the basis of modern cloud computing because everything that you need to run the application is packaged together and possibly can be automatically deployed on the cloud. For instance, you have a Java application and need to install Tomcat server that is needed to run the application. Containers make it possible for you to package your application and the Tomcat server together in a way that whoever installs the application via this container wouldn't need to install Tomcat server individually. Docker. That is nothing else than a software that allows you to build, deliver, and run containers. That's all for today. Thank you very much.